Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webcast. I'm Charlene O'Hanlon, Managing Editor at Media Ops, and I am so glad that you are joining us today. We have a great webinar on tap as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 6 $25 Amazon gift cards, so please stick around. Hopefully you'll be one of our 6 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Controlling Cloud Costs with HashiCorp Terraform. Our speaker today is Kyle Ruddy, who is a Technical Product Marketing Manager over at Terraform. Thank you so much for joining me today, Kyle. It's a great pleasure to have you here.
Oh, thank you for having me. Excited to be here.
Excellent. All right. Well, I know you have a great presentation on tap with a demo. Yay. So I'm going to go ahead and put myself on mute, take myself off camera, and let you get right to it.
Fantastic. Thank you very much. All right. So welcome everybody to this session where we're going to be talking about how we can control cloud costs using Terraform. However, I know we're on Security Boulevard, so I also built in a couple other pieces. Taking a look at some policy as code, looking at some compliance areas as well. So, you know, making it best use of everybody's time. So a little bit about what we're going to be talking about today. We're going to start off with a very high level overview about what Terraform is, just in case, you know, anybody attending this doesn't exactly know what Terraform is. And then we're going to dive directly into policy as code. Talk about a new library that we at HashiCorp just released called the Foundational Policies Library. And then we've got a bunch of live demos that, you know, fingers crossed, are going to go quite well. So diving right in, let's talk Terraform. However, before we do that, I kind of want to get to, you know, the why. Like, you know, Terraform is the how, Terraform's the what, but, you know, why do we want to get to this point? And, you know, throughout my career, I've really been interacting with what's known as static infrastructure. You know, we were always buying, you know, large amounts of hardware, generally on 5 to 10 year life cycles. Not a whole lot changed over those time period. We were deploying VMs to, you know, really be able to consume some of those workloads and deploy those workloads. And a lot of those VMs lasted just as long as the hardware did. So, you know, environment, workloads, all very static in the way that those are deployed. And occasionally we even had a maintenance window, you know, but not all of them were actually planned, unfortunately. But the key in how we managed all of this came down to a lot of it being manual work, ad hoc work. Now, of course, me and my former teams, we would try and go through and automate just about as much as we could, filling up several different repositories full of PowerShell and Python-based code. However, you know, that doesn't always scale very well. So then enter in, you know, this thing known as the cloud. You know, getting into the more dynamic infrastructure, and you know, really the ask of the IT teams are now being able to support, you know, deployment of any type of workload on any type of cloud at any moment in time, like literally dynamic. And you know, the other key thing here is that these requests weren't coming in through tickets anymore. We have these things, this notion of self-service portals, where end users, developers, whoever needs to consume some kind of service logs in, clicks a button, and then they get the service. It's like magic. So on the HashiCorp side, what we do is we kind of break down this whole notion of dynamic infrastructure into 4 different categories with 4 type of IT users, basically. and how they operate within this model. Anything from networking on the console side and service mesh, to security with Vault, to deployment, trying to do and deploy your applications, to operations or provisioning your infrastructure with Terraform. And that's really what we're here to talk about today. The most common use case of taking advantage of Terraform comes around this notion of infrastructure as code. We have this idea of this ability to be able to define how our infrastructure should look, how our infrastructure should be deployed. We can do it as code. It's saved off in a version control system such as GitHub or GitLab or Bitbucket or your whatever VCS of your choice you're deciding to use. And because it's in version control, you can also kind of tell a story as to what your infrastructure, how it got to the point to where it is today, or what changes were being made, and all kinds of things of that nature. It's documentation in essence. Then some of the other reasons why Terraform comes into play is to, this wealth of providers in the ecosystem, being able to control and deploy infrastructure to many different clouds, whether or not that's AWS, Azure, GCP, on-premises sides as well, all kinds of things. The funny provider that always comes up a lot is one from Domino's, where you can use a Terraform provider to deploy your infrastructure to buy and deliver a pizza to you. I mean, it's all over the board. And then the last big use case is around self-service. Being able to allow those end users, those people who are consuming these workloads, to log into a portal and specify exactly what they need. Now, on the operations side, this is where these things such as private module or custom modules come into play, where we can define a lot of these things ahead of time so that people don't, they don't have, open access across the board to deploy anything or however they want. So before we jump into some of the costing and compliance pieces, I do want to talk about some of the new things that have come about here in literally the last week. Because this week we had a little conference, don't know if you've heard of it, but it's called HashiCorp Digital, where as part of the keynote, we announced a beta release of Terraform 0.13. And as of today, at the moment of this recording, it's actually on beta 2 release. And so while I'm not going to go into any demos specific to 0.13 itself, I do want to call out a couple of the really cool updates that you can look forward to and start using today if you want to access that beta. So the first being count, or rather I should say, these are all things that are built into the module block as part of your Terraform configuration. And I'll show you some, if you've never seen a Terraform configuration, I've got some to kind of show you here in a little bit. But as I was mentioning earlier, with self-service, being able to use these things that are known as modules to basically pre-fill in what your resources, what your infrastructure should look like, we've added some new arguments to that. The first one being count, literally being able to say, this module is going to deploy these different resources, these subsets of resources. Before, you had to define that in the resource blocks themselves, internal to the module. Now, with this new feature, you can do it at that top level module area. So you can deploy, however many different subsets of resources and so on and so forth. Now, we can also make that a little more complex, add some logic into it with for each. That's also being added at the module level, so that you can introduce some key value pairs, so that you can add, a little more complexity or handle that more complex logic in the way that you define and create your sub resources. And then lastly is depends on. So depends on, really that comes into play for that 1% time where Terraform can't quite handle all of the dependencies on its own. Terraform understands, it can implicitly understand the dependencies for each providers, modules, and so forth that are going to be used. However, this is that one kind of like area that the Terraform doesn't quite grasp it. So we've added depends on to that to really take care of that. Then we have some other new integrations, specifically with Terraform Cloud and even Terraform Enterprise, so that directly from the Terraform CLI, you can give it your API token. It'll save the credentials locally in your profile, on your local system, and then that streamlines the authentication piece into Terraform Cloud and even Terraform Enterprise. And then lastly, the big one is around the Terraform registry and how we manage some of the providers that are out there. So currently, as of today, the Terraform registry hosts the HashiCorp providers that we've worked on, both ourselves and with some of our partners. However, there's also a beta happening there where there are third-party providers that are out there and even community providers. So basically what's going to happen here with Terraform 0.13 is you're now going to be able to explicitly define what provider you want to make use of. Because not only is there the Terraform registry, but there are private registries that go along with that too. So now you have a lot of granular customization so that you can specify exactly what you want to use as your provider instead of having to maybe overlap a provider that's been added to a public repository. Next up are some updates for Terraform Cloud and Terraform Enterprise. I'm going to make this very brief, but Terraform Cloud was something that was announced last year at HashiConf. Has come a long way since that initial announcement. But to summarize what Terraform Cloud is, if you've never heard of it, it basically takes your local Terraform CLI usage and provides it now as a service out in one of the areas where we're running that. However, it's not just the CLI activity itself. It's also going to be used to maintain your configuration state, which can then be shared with other members of your team. So you don't have to worry about storing your state locally or which cloud or wherever you choose to store your state. You can now use Terraform Cloud, share it there securely across your team. Now there are some other integrations as well for version control systems that I'll kind of show you that act as webhooks. If you make a commit to a repository, that repository is being viewed by Terraform Cloud. It boom, it kicks off a plan and a run to update those infrastructure pieces that have been deployed. There's also a nice API to consume, and you also have the ability to make use of a private module registry that's out there. Now, the new stuff that have been added, we've added a getting started walkthrough because some people open up the Terraform Cloud UI and they're like, oh, this is, I was expecting a little more like Terraform Plan, Terraform Apply, but this is so much more. So we've added some things so you can kind of get an easier path to getting started. And it doesn't matter if you've been using Terraform for years or if you're brand new to Terraform today. It can help you walk through each of those steps. You can tell it exactly what your knowledge level of Terraform is. We also have the ability to automate runs in between the different workspaces with a thing that's known as run triggers. So this is kind of taking a step back from the way that we kind of deploy our infrastructure now and addressing it in more of a application pipeline type of way. So that if this smaller piece of our Terraform configuration kicks off and it's successful, we can tell it to go over to this other workspace, start that plan and apply, and on and on and on. So we kind of have some more reusable portions. We can spread that within our infrastructure itself. And then lastly, I brought up being able to share your states among your team members. There have been some tremendous improvements to the way that we manage our team members through the use of RBAC or role-based access control, even down to the point of how we invite people into our Terraform environment. All right, so let's get into some policy as code here, because that's really what we're here for today as part of this session. So, as I was discussing earlier with this whole transformation, going from static infrastructure to dynamic infrastructure, this notion of self-service, self-service-based catalogs, all of these things that, maybe IT operations, we're no longer the people who are kind of holding the keys to the castle, right? So with infrastructure as code, people can deploy whatever they want to, however they want to. But that doesn't always follow business best practices. That doesn't always follow the individual services that are being consumed with their best practices. And also it gets into a point of just following general compliance policies and rules as well that a lot of organizations have to get into and follow. So we're kind of breaking this down into 3 different subcategories here with embed, enforce, and view. So when I talk about embed, this is where some of the best practices come into play. If you're using AWS or you're using Azure, you want your infrastructure to be making use of tags. This is how we can kind of define and view and get an idea of how our resources are deployed and for what manner. We can get into the point of telling, okay, QA development, maybe you all don't need that high tier premium instance for whatever code's being deployed. We can save a little bit of money and keep that premium, that top level instance for our production type of code or workloads. And then lastly, another cool one that's built in is time to live. So if you know that you only need this piece of infrastructure for 5 days or even 5 hours, you can set a time to live. It'll clean itself up. So very nice things. So you don't have a lot of waste there on the back end. Then we can get into the enforce piece of this here. So not only just because we conceptually have this notion that we've already embedded tags in, but now we can also use policies to enforce that our infrastructure are using those tags, that the development groups are following the policies as defined by the organization for their workload instances. And then we can make sure that people aren't deploying things after hours. We want to be cognizant of people's work-life balance. We want to make sure that somebody's not like, oh, I'm going to deploy this at 6 p.m. In whatever time zone, but then they're not really going to start interacting with it until the next day. So we can now enforce those types of things, as well as just telling people to follow some of the best practices around cost estimation. Lastly, then there's the view. So we can have this consistent view across all of our specific instances. The specified case here is EC2. Then we can also view some of the costs that are going to be associated with the infrastructure, so we kind of have an idea of what's out there and what's running and how much it actually is. So let's talk about how Terraform and policy as code, infrastructure as code really works out to help solve some of these problems, right? So we have our infrastructure as code. We've gone out, we've created a private module registry. On the operations and the management side, the business side has gone through and created some best practices. We've released that as part of a module. It's all defined as code, very easy to see, very easy to validate. And then we can push that out so the consumers are going to be able to see those and easily access them and not be able to change things that they don't really need to. That's all embedded in our modules. There we go. And then when we get to the enforce side, this is where policy as code and the Sentinel engine come into place, because now we can take even what's being defined by our private modules, what's being requested by our consumers, and we can run rule sets against the Terraform plan configurations, as well as the run, as well as the states, to just make sure that they are still continuing to follow those best practices in the end before they actually start consuming any of those resources. And the best part about this is that it's all built into the workflow, so it's automatic right off the bat. And especially if it passes the policies, it goes right on to the apply. No issues there. And then we can also start including pieces from all the providers that are out there. So we're not sticking specifically to our baseline Terraform code. We can do this against our provider configurations as well. And then lastly, this just comes around our infrastructure state, being able to view what that is currently, have access to that, being able to share it throughout our team so that everybody has the ability to manage it. If something were to change or need to change. Lastly, the big one, cost estimation, having an idea of what these configurations are going to actually cost in the end. So before we dive into demos, because I pretty much screamed through that pretty quickly, because I think seeing makes all of this, makes it just that much easier. But before I do that, let's talk about the Terraform Foundational Policies library. So if you've ever used Sentinel before, there've been a lot of comments about how it's basically that blank screen paralysis of the first time you write a Sentinel rule, because Sentinel is based off of its own language. So there are some nuances to that. So it can be a little overwhelming. But we've gone out there and provided a library of policies that are based on the Center for Internet Security benchmarks across cloud. We've put it out there on the HashiCorp GitHub repository. So you can see it there on the screen is the URL string for that. It initially comes with about 50 policies focused on anything from compute to databases, networking, Kubernetes, storage, all kinds of things. And we basically tackled the major cloud providers that were given to us from CIS. So we're talking AWS, Azure, as well as GCP. All right, I've been talking to slides for a long time, so let's get into some demos. All right, so here's what we're going to walk through, and here's our use cases. So we're going to start off by doing a very basic, just trying to understand what the costs look like for a provided infrastructure. Then we're going to go into taking a look at some, how we can apply some best practices to the way we deploy our configurations. Take a look at some inconsistent configurations, and then make use of that foundational policies library to apply that to an existing configuration. All right, so apologies, I'm still a little bit of a Keynote noob here. So let me jump over to all right, here we go. So here is Terraform Cloud. Cost estimation, this is a feature of Terraform Cloud. It's also a feature of Terraform Enterprise. So I'm going to be doing all the demos from Terraform Cloud today. So this is just your basic UI. I've created an organization, this name, and then we're in our workspaces view. Now, when I kind of mentioned some of the updates before about how to get started, how to get using, this top piece right here, this getting started with Terraform Cloud, that's what I was referring to. So it kind of takes you, walks you through the process of signing up for Terraform Cloud, because it does, require you to create an account. You don't want to, store your state or your configurations in a place that, you can't control the access to. Creating an organization, and then we're going to do some of these other pieces. And if you click on it, you can see, just how well defined this actually is on the back end. So if any of this is overwhelming, it'll take you through that whole entire process. So going back to our workspace, let's create a new workspace. So we're going to link this out to a GitHub repository that's in my own GitHub repo here called Basic Site Demo. Then we just create our workspace. So that's going to take a second there to go through. Then I'm going to use some Terraform magic here to go through and configure all of my variables, as well as some Sentinel rules, and attach those to this. So here's, basic site demo. Let's go over to variables. So this is going to reach out to AWS. So I've provided it with my variables of AWS region, because we're going to try to deploy to US West 2. I've given it my public key, as well as my access key and secret access key. Those are all things to ensure that I can authenticate to Terraform, or rather to AWS itself from Terraform. Let's go ahead and kick off queue up a plan. This will take just a couple seconds for it to go through. In this top pane box, we can see that our plan is running. So this is going to be the output is the exact same thing as if we did it locally on our console, just type it in Terraform Plan. So in this case, we see that we have 9 new resources that we're going to be planning to add. Then because we have cost estimation enabled for this organization, we see a subset of the costs that are going to be associated with this. It appears that this configuration is going to be making use of a load balancer. We can see the average hourly cost as well as the rough monthly cost of $18 in total. Then we can see what our compute instance is going to be, which is roughly going to be $16.56. I will address the normal question that comes up right off the bat: where is it sourcing these costs from? It's referencing this from the AWS API. So this is not something that's quite tied into your own AWS account, at least not at this moment. That is definitely a feature request that has come in that we are certainly taking a look at. So just with a single checkbox to our organization, this is how we can start viewing costs. But then we want to kind of build on this. So okay, great. We have this notion of how much it's going to cost. There's no restrictions to that though. So this is where our policies come into play. So we have a couple Sentinel policies here. The fun thing is that I normally don't do this demo on Fridays because our very first check here is checking to see if it's read-only Friday. We don't want anybody to deploy any code to the environment on Friday, so we can build that in as a very basic Sentinel rule to see, hey, look, organizational best practice, read-only Friday, don't do anything that's going to mess up my weekend. So in this case, we can see that it's failed. We can see that our rule here is failed. We can also see that it's only set to soft mandatory. So Sentinel has 3 different restrictions or rule outputs or enforcement levels. That's what it is. We have advisory, soft mandatory, and hard mandatory. So in this case, soft mandatory. This will allow you to continue forward. However, the next one is hard mandatory, and it's just saying, hey, this is it's not of the instance type that we want it to be, which I think I moderately cheated with the output code here, but basically this is taking information from your Terraform plan and trying to apply it to the rule set itself. So in the end, our apply will not actually run. So, not even any option to go ahead and do that. So I'm going to set up our next environment here. There we go. So going back to our workspaces, we now have 2 brand new workspaces. This is where we kind of start separating out how we use and define our workspaces, because now we have we're doing the same basic site using that same repository. However, now we have one on the development side and we have one on the production side. So let's choose our production environment here. Again, I'm using Terraform to configure Terraform, so it's kind of a funny situation right there. We have our region set, we have our public key, we have our access keys all defined. The big difference in this is if we go to our version control, we can see that we are using our same basic site demo repository. However, we are using our production branch from GitHub itself. So that includes some of the customizations that we can make use of. So Terraform has the understanding of what's happening on that repository within whatever VCS of your choice is. You're not limited just to GitHub, I should say. So we went ahead and ran our plan again. This time it's going to still continue to add 9 different resources. because this is a production environment, see a drastically different cost estimation. So in this case, we can see, our load balancer, still $18, still using the same size there. However, our compute instance here went up drastically. So it went up from, a couple dollars to now $267 per month. But now we have a couple different Sentinel policies and rules that are out there that it's checking for. So scrolling up here, we have, and I'll go through these rules here in just a second to kind of show you what's happening on the back end with these. So our first policy right here is around costing. This is just saying, hey, is this deployment of our infrastructure going to cost less than $10 a month? So in this case, of course, we can't even deploy the load balancer for that. So we should probably go back to the business side and say, hey, everybody, $10, I'm really going to cut it in this particular situation. So we'll need to go back through and do a business review of what that should actually cost. And we can see that it's using an advisory level. So in this case, the advisory failed, but it's fine. We can still keep on going. Then the next one is around time. It's still Friday when this session is being recorded. So read-only Friday, not going to deploy, but it's still a soft mandatory. So we could override it if we wanted to. Then the last one. So we're trying to see that this environment should be making use of a T2.large instance type, whereas it's finding that we're trying to use T2 with a 2 extra large instance type. So it's going to hard stop that one, hard mandatory fail. And again, we can't apply this. Then we can also go back and verify it. So we can see the output from our plan here. If we scroll up towards the top, let's see, where is our instance type? There is our instance. So as we're using an AWS instance resource with the name of web, and our instance type that's trying to be deployed here is T2.2XL. So not going to work in this particular situation. So let's head out to GitHub real quick. Apologies, this should have been up already, but it was not. With the new GitHub view, it's a little interesting. So what we're working with here are known as policy sets. So those are those 3 different rules that are being applied at the very same time. So the policy set itself is defined at this top level sentinel.hcl file. This is also where we set our enforcement level. So if we wanted any of these to change, we do that here. Then these policies end up aligning with the names of the other ones. So if we look at our AWS costing situation here, we're importing a couple packages. So we're inputting our TF run because that's where we're pulling some of this information from, as well as decimal, so that Sentinel knows and understands how to interact with numbers that are a type of type decimal. So from that point, we use our TF run to pull information from our cost estimate to check our proposed monthly cost, and then we're making use of the less than to say, okay, we want the output from that to be less than 10. And then the end result of our Sentinel policies, our rules here, is true false. So it's either true and it goes forward, it passes, it's all good, or false, it does not pass our sniff test, and then it goes back to our Sentinel HCL to see what the enforcement level is, to see what Terraform actually does with it as part of that run. And these are all very simple examples. There are some examples out there that get incredibly complex. This one I even built in some logic to it so that we can, depending upon the name of our workspace, that will change which instance type is being used. So if we go back into our Terraform Cloud environment and I ran that basic site dev, instead of looking for the T2 large like we saw, it would actually be looking for T2 micro. So in theory, that's what should happen. And here, I'll just go ahead and kick that off to, because I believe that is all set while I switch over to our next development environment here, our next workspace. That'll take 1 second to create. All right, there we go. That should be all set. Our plan is already run, where it's completing right there. Yeah, so again, still making use of that same repository, just using a different branch to define that. Our costing has gone back down to a reasonable level. However, this load balancer is still above that $10. So either we need to go back and change it to make sure that our cost estimation only looks at the instance type, or we need to address some of those business constraints. However, in this particular situation, our instance type passes. So in this case, we can kind of see the whole variety of outputs here. So we can see our advisory failed, but it's development, so that's fine. Our time fails in a more strict way, because of course who wants to work on the weekend, but our AWS instant type passes. So then down here at the bottom, because that was a soft mandatory, we can now override and actually provision out this Terraform configuration. We're not going to do that. We are going to move on to our next demonstration. So a lot of times when I'm talking about some of these areas, a lot of times it comes up and where we do a lot of AWS demos. So let's switch over into Azure and take a look at a different configuration here that's known as HashiCorp Azure. And we're going to be doing a couple different things so you can kind of see what's happening within this environment. Everything is going to be, our execution is going to be remote, so it's going to be performed within Terraform Cloud. We're going to change our apply method so that it's auto apply, meaning that if any changes happen to the GitHub repository, it's going to go ahead and change. And then also another cool little option here, we can change the different Terraform version that we're using. So you're not restricted to the latest and greatest, even though we generally advise that. But you can go all the way back as long as you want. Let me save these settings real quick because we are going to be making some changes in this situation. Now I've also pre-populated our variables area here so that we have our client ID, secret, our tenant ID, and subscription IDs, and then we have a prefix. This is our within the DevOps.com area, even though it's Security Boulevard. So I've added DevOps.com as our prefix. So let's kick off our plan queue here so we can see a little bit of how this looks if we were to run this on Azure. Note that because this is using a different cloud service, it's going to be creating a little bit of a different amount of resources, but in the end, our plan, our cost estimation, our Sentinel rules are still going to be viewed the same way. So for this application, this website, as it were, it's going to deploy 8 different resources instead of the 9 that the last one was. That's not a comparison in between the services. That's just how the configurations were written. Looks like my apologies. My organization is still having some issues with the cost estimation. That should be something that's only on my organization. That should not impact you. Apologies about that. But if that were to be up functional, you would see the very same similar output as what we were seeing in our last demo. And then it comes to our policy checks. So we have a very similar We named it this time Azure time. Again, read-only Friday. Don't want to mess up our weekends. Then in the bottom, instead of looking at our T2.micro, we're looking for a standard A0 Azure instance type. So because this is a soft mandatory, again, we can go ahead and override and continue. But we're not going to do that. We are going to make a change to this. So let's go out to let me show you our Azure rules here. Come on, GitHub, policies Azure, there you go. So in this case, we have our two different rules that were set up and configured here, our instance type. This looks very similar to our previous rules. Just saying, hey, our desired VM size should be standard A0. We're going to use tf-run to pull out some information about what our workspace is, so we can kind of give some verbose language within the output of our rules. And then lastly, we have our, pulling out the information about our configured VM size, making that comparison. In the end, it's just true, false. Okay, so that's all good, but let's make a change here. So let's go to our VS Code example here. Here's our HashiCorp. That's our Terraform configuration right there. Let me find where we're going to add a managed disk to this deployment here. So I'm just going to paste that in. This was just a standard Azure managed disk. The account type premium LRS, empty, of about a terabyte in size. We're going to save it. We can see over here, thanks to some integration into VS Code, we can see that we've made a change to that file. I also want to take just a brief second here, call out to our Terraform extension that was just recently announced, was just recently released as a 2.0, in fact. So this really allows you to make the best use of some of the IntelliSense that Visual Studio Code has to offer. So huge improvement there. If you're a VS Code user, it's fantastic. If you're not, if you prefer Sublime or anything of that nature, we do have a language server that has also been added out there for you to make use of. So let me add my commit message here. Oh, I need to stage it. Sorry about that. And then we're going to push this out to our GitHub repository. Now, in our demo environment here, if we go back up to our HashiCorp Azure, we can see that this new one has kicked off. So this is my commit message right here, adding managed disk. And because of the integration that Terraform Cloud has with GitHub, it's gone through and already started our plan. So in this case, our plan has updated. We now have 9 resources compared to the previous 8. The cost estimation, unfortunately, is probably going to fail again. However, our policy check is still going to look the same. We're going to discard this because I want to show you one more thing. So we just added a managed disk. Now, most organizations have some controls or follow some sort of compliance for how they use managed disks. So we're going to see how we can take a CIS benchmark and apply it to our Terraform configuration here. So we can make use of this nice little call out button here for our foundational policies library. This is going to take us out to GitHub. We can see, this is the GitHub repository, well documented. So I'm not going to cover too much about that. But right now we just have policies pre-created for the CIS benchmarks. So we can click on CIS, and we can go through here to Azure because we want to take and use a policy against that managed disk. The managed disk is actually going to be in the compute section of it because what we're doing is we're trying to make sure that all of our managed disks are encrypted. We're trying to be secure. So we can take this this set of code right here and use it within our rules set, our policy set rather, to reference this rule as it's been created and documented by us at HashiCorp. Now it looks like I'm running a little late on time, so I'm going to go directly. Going to cheat a little bit. I'm sorry. Do not recommend doing this in really any environment except for a demo environment. So I'm going to just copy and paste in that policy directly to our sentinel.hcl. Again, this source argument is the one that's doing all the work going out to that foundational policies library to pull that in. Not even making any commit messages, so apologies. We're going to hope for the best from our onlookers from the demo land. So if this works as it should, I should be able to hit Q plan again. It's going to run through that entire process to check out and make sure that our configuration is what it is. There we go. Still going to have 9 resources to add. It's going to again fail at our cost estimation piece. Hopefully that's just something that's limited to my environment and not something that you see in your own environment. Yes, then we should get our policy checks. So we can see that we now have a third policy that was included as part of this. So we have our Azure time, that's our read-only Friday. We have our Azure instance type, making sure that we are looking for that standard underscore A0 VM size. And then lastly, we have this new rule that we've imported directly from the foundational policies library, saying that we are following CIS Benchmark 7.1, which is ensuring that all of our managed disks are encrypted. So these are going to be a little more verbose than the very basic rules that I created. So just a heads up on that when you're seeing some of this output here. But the key point here is just the encryption settings. We can see every step of this way exactly where it failed within that benchmark. So we have a really good idea of what's happening. So with that, let's go back to that. That kind of wraps up our demos. So let me go back to our slide deck here. So throughout that demo period, we went through, took a look at how cost estimation works. Just that simple bar read out exactly what our, particularly for AWS, what our load balancer and what our instance type is going to cost. It would be the very same in Azure if it were working in my environment. Apologies again. Then we took a look at Sentinel, the policy as code engine, and how we could use that to configure some cost limits, how we could follow some corporate guidelines, specifically around, don't deploy on Friday, making sure that our development environment matches a specific instance type, making sure that across the board our infrastructure is unified. And then lastly, we pulled in that managed disk, took in a CIS benchmark for encrypted disks and applied that to our Terraform configuration just by copying and pasting 4 simple lines. So a couple additional resources that I want to call out before we get to any of the questions that have come in throughout, which it looks like there are quite a few. Want to call out the download about Terraform 0.13. It's in beta 2 release right now. It's out there. The release notes are there. It includes all of the information about what's happening there. If you're a Mac user like I am, check out Homebrew to just brew install. Also check out Terraform Cloud. That's how we get access into some of those pieces for cost estimation, as well as the Sentinel policy as code engine. Very simple process, app.terraform.io. Boom, you're in. And then, when you get started going down the path of using policy as code, kind of applying those guardrails to your environment, check out the Terraform Foundational Policies Library. It's an excellent source of pre-written rules. Even if you're not going to make use of them, they're a really good resource to verify what you're trying to do versus how those have already been pre-written. So with that, my name is Kyle Ruddy. I do technical marketing at HashiCorp specifically for Terraform. Here's some of my contact information. Please feel free to reach out. I'm very active on Twitter especially, and occasionally on LinkedIn. But if you have follow-up questions that we can't get to here in a second during the Q&A, that's a great place to find me. So with that, let's toss it over to some Q&A.
Okay, we've gotten a lot of questions in so far. Before we get started on the question and answer period, I do have a quick poll that I want to send out to folks. So I'm going to go ahead and launch that now. It should be showing up on your screen. Would you like to learn more information about Terraform Enterprise Operation offerings from the HashiCorp team? So you can select from one of the following, yes or no. We'll go ahead and give you guys a couple seconds to go ahead and make your selection, and then we'll dive right in. I think we'll have time to get to one or two questions, but obviously we're not going to be able to get to all of the questions. But please know that the folks at HashiCorp will be getting a copy of all of the questions that come in. So if we don't get to your question during today's webinar, I'm sure they'll be more than happy to follow up with you. So it looks like we've got more than half folks who have answered. So let's go ahead and close this poll out. And all right, we're good to go now. Let's go ahead and jump right on into those questions. Our first one here, let's see. I have so many of them here. Does Sentinel only work with Terraform Cloud, or can it be used with the community version?
Yeah, so right now at this point in time, Sentinel is something that works with Terraform Cloud and Terraform Enterprise. One of the things that comes up a lot is around the usage of Terraform, the open source, the community CLI version. That's not something that we can do today. That is something that we're looking into, that we've heard from the community. Like it's a tremendous ask, and we're trying to see what we can do to make something possible there. There are some things like if you do get started with Sentinel, there is a Sentinel CLI that's out there and available for download. That's not going to give you access to the entire Sentinel policy as code engine itself, but that will give you the ability to test out some of your own rules on your local machine. So just be aware that the Sentinel download that's out there, it's not like the full version, but it's a pretty good one to test some stuff out locally before you send it out.
Okay. All right, great. Next question here. Can you deploy policies at a corporate level?
I'm assuming that we mean that at the organization level, and yes, you can. So what's happening on the back end is that when if I would have had a little more time, I could have shown you how the policies are configured. But in my particular demos, what I was doing was I was taking these policy sets, that where we established that sentinel.hcl, and I was applying that to the specific workspaces. However, if you have a broader subset of rules that you would like applied across the board, because some of those things were very, they were very general. Limiting which day you can deploy things on. I could apply that to everything in the organization. So at that point, there is the option to say, yes, apply this for all workspaces.
Okay, all right. I think we have time for one, maybe two more quick questions here. Here's one for you. We recently implemented a hybrid cloud solution based around the Microsoft Azure stack with Terraform HCL scripts, provisioning and instantiating the nodes. These make calls on other on-premises nodes via Ansible. Red Hat informs us that it wouldn't be supported by them. So what does HashiCorp have to say? What's your position on this?
That is a very detailed question. Let me see if I can.
Yeah, it is.
Let me see if I can find that in the questions. I mean,
Well, I think it's the fourth one down.
So I mean, going from off the top of my head, you know, the basics of what's happening here is Terraform is used for infrastructure deployment. So it's basically applying that base level for your infrastructure. Now, we at HashiCorp and them with Ansible, Red Hat, IBM work very well together. We've done many joint ventures. We get along quite well. So, you know, maybe Ansible doesn't want to support the Terraform piece of it, but you can always come to us at HashiCorp and ask for that support, because there are a lot of customers. They're companies, organizations who are, you know, deploying their instances with Terraform, and then they're using Ansible, Puppet, Chef, what have you, because I don't want to limit this just to Ansible, for the configuration management piece of their application or their workload deployment. So I think to summarize, what I'm assuming is that Ansible was saying, you know, come to us for the Ansible pieces, but you should go to HashiCorp for the Terraform support pieces, I should say.
Gotcha. All right, great. Well, I would be remiss if I didn't ask this last question, which is how can I get started with Terraform today?
So getting started with Terraform, going back to that call to action slide, you know, heading out to the HashiCorp Terraform GitHub repository, checking out the different releases, downloading Terraform CLI, going out to app.terraform.io, signing up for Terraform Cloud. It's free. So, you know, even if you don't want to do the CLI portion on your individual laptop, hit Terraform Cloud and you know, sign up for a free account, and you can do those remote runs, manage remote state, and a bunch of other things, you know, directly within Terraform Cloud. Super easy to get started. The getting started workflow will also walk you through the entire process.
Excellent. Excellent. All right, great. Well, we're 3 minutes to the top of the hour. Unfortunately, that's all the time that we have for the question and answer period. If we didn't get to your question, as I said before, the folks at HashiCorp are getting a copy of all of them, so I'm sure they'll be more than happy to follow up with you. At the beginning of the webinar, I did mention that we'd be doing a drawing for 6 $25 Amazon gift cards. So without further ado, let's go ahead and get to that. Today's winners are Greg T. Congratulations, Greg. Jared S. Congratulations, Jared. Michael T. Congratulations, Michael. Rachel T. Congratulations, Rachel. Sarah J. And our final winner today is Wilson M. Congratulations to all 6 of you. We'll be following up with you via email, so please check your inbox, and because that's how your gift card's coming to you. So if you don't see it in there, just check your spam folder, because you never know. So I do want to thank everybody who did submit questions. So many great ones. I'm sorry we weren't able to get to them, but please, you know, as I said before, you know, HashiCorp is going to be able to follow up with you. Also want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we are sending out an email that contains a link to access the webinar on demand. And the webinar is also going to live on the Security Boulevard website, so you can always go look for it there. Just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. Kyle, thank you for such a great presentation today. Love the demos. Good stuff.
Thank you very much for having me again. Thank you all for joining.
Yes, yes, and especially on a Friday. Thanks so much. I do want to thank the audience also for joining. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Have a great weekend, and then please stay safe.